What's up? Good morning. Hey, matey. Hey, Freddy. What's up, man? What's up, today? So I'm working on Gunslinger today, which is the framework that I've used for all my videos. So I need to add some immediate mode drawing capabilities to the graphics subsystem right now. So that's what I'm working on. So that you can use this to do custom UI, use it to do debug rendering. You could use it to make an entire game if you wanted, because there's going to have functionality for being able to push verts and stuff like that into it. And it'll get drawn with as few draw calls as possible. So you could do like a immediate mode GUI with it, stuff like that. It's lightly modeled after the way that Raylib does it, although Raylib does like push and pop of immediate states, which I'd like to do that eventually. How am I doing? I'm doing well. How are you guys? I don't need to submit. Tired, just relaxing? Yeah, I hear you. Is it nighttime over there where you are? 'Cause I'm in the States, so in the center of the States, so it's fairly early in the morning. Uniday, waiting for the game jam. Yeah, man, I want to get this up to the point. So what Uniday's talking about is I'm going to announce a game jam using Gunslinger. So I'm going to make a couple of videos going over the framework, how to use it, what all's in, what all's in there, and then try to announce a game jam. Get some people that are interested and maybe want to try it out and use it. I'm from the moon. Cool. All right. I need to set this. I think I'm just going to try this in an example real quick. So let's do simple triangle. Do you cross stream on Twitch? No, I don't. I probably should though. push that. You get new viewers if you stream on the technology section. On Twitch, you mean? Because if that's the case, then yeah, I'll look into how to do that and start doing that. Because I've done some gaming stuff. Not many streamers in that category. Cool. Yeah, I'm an engine dev by trade. So I've worked in indie companies. I've interviewed, gotten job offers at AAA. I have colleagues in AAA. Right now I work as an engine lead for a smartwatch company, actually. So I enjoy game stuff, but I enjoy engine work a lot more. So if, could get people that are interested in getting behind this framework, maybe people that want to adopt it and use it. The idea is to get it to be kind of like Raylib, but have much more functionality than what he provides. Yeah. So we should be able to do something like this. Just draw a line. Hello, Alexander. Have you ever heard about something like Open Frameworks, but for C instead of C++? No, I haven't actually. If you know something, then I'd be interested to hear it. this. It's stupid. How's the game mechanics series coming along? It's good, actually. So I was working on... So if you've watched any of the previous streams I've been doing, working on Contra. So I was going to remake the first level. So I've been working on that. Yeah. So it seemed to be popular. And I like doing them. I enjoy engine work more, honestly. I just enjoy making tools, man. I don't know what it is. Okay, see you, Freddy. I guess you're leaving. So I'm gonna pass in. Let's go from 0, 0 to 400. 400. And let's do a white line. Color T. That's right, because I didn't actually set these functions. Hey Christian, how you doing? What am I working on? I'm working on adding some immediate mode rendering to this framework I've been working on. So that if I go to the source here, so the way this graphics API works is that I have a virtual machine that queues up a bunch of commands. Are you using immediate mode for debug drilling? Yeah, that's one thing you could use it for. But it's this graphic subsystem that I use. It works off of a like a small virtual machine, basically. So you queue up commands and you push those into command buffers. And it's just a big byte array, basically, like commands and then data for the command that follows after it. Pushes those back into a command buffer, queues those up. You can do those in any thread that you want to, and then on the main thread, you submit your command buffer to the graphics subsystem, and then what it does for the OpenGL implementation, submit command buffer. It grabs that command buffer, grabs all the commands, and then it rips through them, looks at the opcode for each of them, grabs the information out of the byte buffer for those commands, and then it applies that. So it'll submit the information to OpenGL at that point. So this has to run, this submit function, this has to run on the main thread. Pretty much everything else can run on opposite threads, right? So this is how you multi-thread graphics, by the way. This is how you do this. Because if you guys are familiar with OpenGL, or really any graphics API, pretty much you create a context on a single thread, that would be your main thread, and then you have to do all your operations off of that main thread. So you can't, for instance, have a vertex buffer that you want to update on a separate thread where that information is held on the main thread. But if you do something like this, you can queue up those commands, and then you do them all on the main thread, right? And then they work. So that's what this is here. So for all of my other, let's go to like the, if you guys have watched the sand simulation, right? So the Noida video, render scene. So there's an actual render scene function. So if we look at here, we're doing that same stuff with the command buffers. So we queue up commands, right? So we set certain state, depth, whether or not we're gonna have depth testing enabled, set the face calling that we want to use. This is binding frame buffers and render targets so that I can do an off-screen render target. I do that for post-processing. And then here you're queuing up everything, rendering that into there. And keep in mind, at this point in the frame, none of this stuff is actually getting called in OpenGL. It's all just commands that are being dumped into this command buffer to be processed later. So again, we're binding another frame buffer, and this is for all the post-processing. And then here's back buffer stuff. And then here's the actual thing that kicks off all the commands to be looked through, and then queue up actual OpenGL commands. So that's how all this works. So what I'm doing now is doing just some really simple kind of hold your hand immediate drawing stuff, right? So it's a lot of it is setting up stuff like this just in the back for you so that you can call really simple commands like, hey, draw me a line to the screen, draw me a cube, you know, fill it with this color, draw me a sphere or circle or something like that. So that's the idea. That's what I'm working on now. That way you can have some utility to be a little more simple than it is right now. Right now, I have a lot of granularity with this. You can do a lot with this framework, but it kind of requires you to have cool select Vulkan command buffers. Yep, that's it. It's pretty much in. I mean, This is how most renderers are written, sort of, because you have to be able to multi-thread your graphics operations, right? You're trying to hit 60 hertz, you're trying to hit 33 hertz, whatever you're running on. 33 for most newer consoles that come out, at least for like first generation games. You have to be able to hit, let's say, 33 hertz. You can't do everything on a single thread, right? And you have a lot of stuff that you want to be able to do in the back end on different threads. So like you'd have like an IO thread typically, and then you'd have like a job system, at least in modern engines right now. And then you would have on the main thread submitting all your actual graphics commands to the GPU because it has to go on a single thread. Or at least the submitting of all that stuff has to go on a single thread because that's where your context is held. So you have to be able to do stuff like this. But yeah, I just want to be able to have simple utilities for being able to draw like just debug information. But also you could use it to make a game if you wanted to. I mean, if you had a game that just needed simple primitives and stuff, you could do that. But for now, I just want something on the screen. I'm not seeing it, so I'm probably gonna have to step into Visual Studio and start walking through. What was your engine dev learning path? YouTube, when I started out. So I learned C++ through YouTube, just did a bunch of exercises. For game dev stuff, I started with console games, made like tic-tac-toe and chess and all that kind of stuff. And then when I wanted to get into graphics, I just went on YouTube and found videos covering SDL and OpenGL, stuff like that. I was confused on what the difference was. I think most people are. I wasn't sure what SDL was actually used for. I wasn't sure what OpenGL was used for. Like, I wanted to do graphic stuff. I was like, okay, well, what do I need to use for that? So learning the difference between those was pretty important. So for those that don't know, SDL is just a platform layer. It's just an abstraction for your platform, for your OS. So that way you don't have to write a platform layer. GLFW does the same thing. SDL has some graphic stuff, but you really shouldn't use it for that. OpenGL itself is the graphics API. Let's see. And then I got a job as an engine dev at an indie studio. Was there for a couple years. And then I've continued to do engine work since. Does the OpenGL backend batch state changes, or is that all left to the other threads? Yeah, so right now it doesn't do it exactly the way that Vulkan does. So I know what you're talking about. You're talking about actually grabbing or actually wrapping up particular like pipeline states. Is that kind of what you're thinking? Like you would in more explicit graphics APIs? It doesn't do that right now. What I'd like to do eventually is fundamentally change a lot of this stuff and then switch it over to being more explicit. That way it'll more easily fit into the Vulkan backend whenever I get there. Because right now I only have an OpenGL implementation. But if I make it more explicit, then it'd be a lot easier to be able to do DX12 and Vulkan in the future, and then Metal maybe, if I even care about that. Cool, so you're mostly self-taught. Yes and no. Initially, yes. I learned a lot from my couple years at that studio, just with a bunch of old heads that knew a lot. But a lot of the stuff I do now is all self-taught stuff. It's just I have kind of some fundamentals down, and I come up with stuff and mess around, and I'm comfortable enough to do that. I don't know if it's the right way to do it, but it seems to work, and I like it. So, let's see. All right, so this is not working. Yeah, eventually the idea is to get all this stuff out of the way, so you should be able to do something like graphics, immediate, draw a triangle, right? So then this entire thing becomes like this, just a really tiny, for the most part. All right, not seeing my line, so let's go ahead and pull up. Really want to go here. Okay. I guess I'm going to need to compile. There we go. Tell you what, let's go ahead and, we don't need the, let's do this. I don't really give a shit about this triangle, so we're not gonna do this, 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 we're just gonna do the immediate mode stuff. That will keep everything else small. Right now it's 3.3, so no, I don't do bindless or indirect. That's what sucks about doing frameworks like this, is that you want to target Like I don't necessarily care about targeting 1.1, although I might. I need to target OpenGLES as well. But I want to write somewhere in here. What am I trying to say? For not modern OpenGL, but I mean at least 4.0, right? I guess the issue is that I'm targeting Mac as well. So this is Windows, Linux, and Mac that this currently runs on. And I don't have any abstraction right now to go between are you on 1.1, 3.3, or 4.4, 4. Is it 4.3, 4.4 and above? So I need to add that in. But currently, no. Nothing indirect or bindless. Because Mac doesn't support those things until I add those into the framework. But that's one of the things that needs to get added in. Just gonna start this back up. Good. Tell you what, I don't need to just end. Good. Let me submit. Okay, so we grab our opcode. So it's set view clear. Set viewport. So far so good. We're binding our shader. So this shader should be 1. Yeah. Yeah, so like stuff like this, like binding uniforms, this is all, you know, this isn't bindless stuff, right? So it's not using UBOs or any of that kind of stuff. But it will eventually. But I think what I'll do, like I was saying earlier, is convert this all to being more of an explicit API so that you have states, and then I'll convert that down to implicit APIs if I need to, depending on what you're targeting. So if you're on OpenGL 1.1, it'll switch that down and do something like, shit, I don't know, probably it'll have to do immediate mode OpenGL. If you do something like 3.3, then you could do actual shader pipelines, but it's not going to be bindless. And then if you do anything, 4.4 and above, then it'll be bindless operations available. Same thing with compute shaders. Like I wanted to have compute shaders in here for a while, but I haven't thought about a good way to be able to separate between you're on Mac that doesn't support them versus you're on some platform that does. So it's tricky to get that right. Hey VMA, adding new features. Yes, I'm adding new features to the framework. So right now I'm doing immediate mode features added to the graphics subsystem. So you could do debug drawing and really simple drawing of primitive shapes and whatever else. Kind of similar to the way Raylib does it. Yeah. Uniform type, this would be a map 4. Should be another map 4. Oh. Oh, that's the issue. Yeah, let me change that. So this should be And then when I get to this, I don't know if that's going to fix it, but that was at least an issue. Typecast, color 2 to F32, 7. Oh. Yeah, you know what, we're not doing this. We're gonna do I don't want to mess with it. Data. Okay. Draw a line. What's up, Ralph? And this should just be a V4. This won't change anything though. Just realized this will not change anything. Yep, okay. The reason it won't change anything is because in the shader, I'm just setting the color directly anyway. Alright, well, what advice would you give to someone looking to get into graphics programming? Learn C would be my first bit of advice. If you're not comfortable with C, get comfortable with it. And then after that, I know a lot of people that say don't learn OpenGL because things are moving away from it. I would say still learn it. I mean, OpenGLES isn't going anywhere. Not for a while anyway. So I think it's still valuable. I get offers for jobs, at least 2 a week. Someone wanting a graphics programmer that knows OpenGL. So learn that. Learn math. So you need to know linear. Get comfortable with that. At least vectors, matrices, and quaternions. Quaternions less so for graphic stuff. It's more of a physics thing. But quaternions are so tied into games themselves that, I mean, just get comfortable with them. I don't do graphics programming these days without quaternions anyway. I think they make transformations easier. So VQS transformations using quaternions, I recommend it. It's a lot easier than having to deal with complex matrix stacks. So, yeah, those things. So, get that data. Our shader is constructing properly. Location 0, location 1. That's all good. Oh, that's wrong. It should be a float 4. So our vertex layout was incorrect. See, this is why stepping through your program is important. Don't just drop print statements everywhere. Step through it, because then you actually catch stuff like that. So that was incorrect. Our vertex layout was incorrect. So that means that all the vertex that was being dumped into this vertex buffer was not getting set up correctly. So let's go ahead and recompile. Hey, okay. So there's my line. It's huge. I know the reason why for that. Immediate draw line. And again, we were going from 0, 0. If I don't do a camera, depending on your goals within graphics, you should work on implementing papers as well. I've never written a paper. Well, I'll take that back. I've written one, or co-authored one, but I don't know. It depends on your goals. I mean, if you want to be a research developer and you want to submit stuff to like SIGGRAPH or whatever else, there's one guy in my Discord that I think he's going to be on that path. He seems like he'll be in the university path doing stuff like that. I never had the mind for that and never wanted to do that. I am more than just a graphics developer. I'm a tools developer more than anything. I enjoy making tools for other people to use. So part of the reason why I enjoy making this framework and why I want to continue working on it is I would like to get it to some level to where people in the Discord are using it to make stuff. So I plan on getting this up to such a state that I'm going to announce a game jam with it, and anyone that's interested in using it to make something to show off, that's what I'd like to do with it. So have like small game jam and take the place over a week or something, work on it, as you'd like, submit your code, and also submit like video of it if you want to go over talking about it, kind of the way that Miz does his game jams. I think he does a really good job at that. And then I'll do like a video showing community creations. So I'd highlight what you made, go over your code, give you feedback on it. That's kind of the idea. So it'd be kind of like a teaching moment for anyone that's interested. Also a way to get your stuff highlighted. Let's go ahead and not do this and see what I get. Okay. Talking about situations when you want to implement a cool technique with poor. Yeah, definitely. If you've got something cool that you've come up with, write a paper, make a video, make a blog, something like that, show it off. Definitely. Get recognized for what you do. It's important. So I think maybe the ortho scale. Okay, let me think about this. So I would like to do yeah, if you're not in the Discord, there's a link in the description. So feel free to join. Tons of engine developers, graphics developers that'll answer any questions you have. And we have people from beginning, intermediate, professional, in college. There's close to 300 people in the Discord right now. So, okay. We are drawing to the screen. We are good there. Okay. There's no issues right now. So the way I'm drawing these lines, by the way, is that they're just quads. Okay. So that's kind of the way that you handle immediate mode stuff like this, is that in order to do a line, you just want to be able to push vertex data. In order to draw a line, you just want to have a simple quad, right? Let me actually go to where I'm pushing back the line. Yeah, it's down here. So it's a thickness of 1. So the quad itself will be, like, it has a thickness of 1.f to 1.f, right? So what you would actually do is scale this by 2, and so now it has okay. So now it actually has a thickness of 1. But the idea would be that it's actually the DPI of the screen that I'm respecting. So if I'm on a screen that's 1920 by 1080, and I do a thickness of 1, I want it to be 1 pixel. But there's no real way to do that without transforming this data myself on the CPU, which I don't necessarily want to do. This is gonna be weird. But why would it be like that though? You have a thickness of oh, but I'm not. Maybe that's why. 'Cause it shouldn't be that thick. No? How do you handle buffer updates within the command buffer? That's a great question. Christian, I can tell you you work with this stuff. Does the data get embedded into the stream for small stuff, or how does the data get protected somehow? It gets embedded into the command buffer. Yep. Yep, that's how it works. It's the only way to do it. You have to copy the data over. So if you wanted to do like updating the vertex, like if you have a vertex buffer and you want to update its data, right? You have to, whenever you call that command, it updates all the vertex data and it pushes that back into the stream, and then it reads that back. So in my byte buffer implementation, there is, where is it? There's a bulk read and bulk write. So if you want to push back like all the vertex data, you do a bulk write of all that stuff. It just pushes that entire stream back, and then you bulk read it back. Let's see, where is that? So right here. So it reads out the vertex data that you want for the VBO and the VAO that's using that binding. Temporarily grabs all of that bulk data from the byte buffer, and then it buffers that data and pushes it. So I do have non-thread safe commands. So if you had something that you were just running like on a single thread and you weren't planning on threading anything, there are commands to be able to just update that stuff directly on the main thread. So that way you don't have to push it back into a command buffer. Actually constructing vertex buffers is the same way. You have to do that on this, like constructing resources has to be done on the main thread. So you don't push that stuff back into a command buffer. So shaders, texture handles, vertex buffers, index buffers, things like that. Good question. Uniforms, yeah, all that stuff. I'm gonna get some more coffee real quick. Alrighty. So this can all change. Let me go to where, let's see. The issue right now is with the camera, the way that I'm projecting all that stuff. I'd like to fix this because I don't want to have to change the camera settings for this immediate mode stuff. But if I did like something like this. I don't know, a lot of this is really funky. Yeah, okay. Yeah, it'd be something like this. So set camera, set camera, set camera, and pass in the window. I do not like this in the slightest. Void, back to yeah. I do 1,000. There's gotta be some reasoning behind this. I'm trying to think here. Actually, 1,000 would make sense. So I have a near and far plane. So if you do 1,000, that should give you 1 pixel, right? So if you do 1, that's basically squishing down a depth of 1,000. If you do it 1,000, that puts it at the back plane of the frustum. And that gets squished down. Oh, does that make sense? So I'm going 0, 0. So that's another thing is 0, 0 now is right here in the center. So really I want to position the camera so that 0, 0 is up here. So it would need to be and then we're not changing that. Why is that happening? So we're at 0, 0. We want to move it over that. So that puts 0, 0 at the bottom left. All right, I gotta think about this. Yeah, so that's up there. That's still not quite right. Interesting. Yeah, that's not very well. Sound like cats fighting. Yeah, So we got a couple of cats and they hate each other. I might need to do instead of this, just keep see what would be the best way to do this. Let's get this to where so this is in world space, okay? So all this is in world space for this thickness. Actually, this is in window space, right? It's going from window space of, yeah. Man, yeah, that's gonna be interesting. I'm gonna have to make this simpler. Shit. Damn it. Oh, shit. Haven't used GL immediate mode. Yeah, this isn't even immediate mode. So it might not even be correct to call it immediate. But I probably should do something like that. So immediate mode, I should store like a stack for like a matrix stack. Because really that's all I need. A stack for shaders, textures. What else? Just various, like just a state stack for the immediate mode. And then whenever you want to apply a camera, you would say, you know, like immediate push camera, and then you know, push your camera onto the stack, do your operations in here, pop your camera, right? So then it would take you back to whatever you had before. And then what this would do is it would create a view projection matrix to apply to all verts that you're going to push into this immediate vertex data stack. This is probably how I'm going to have to do this. So all these transformations are going to have to be applied on the CPU. I think that's really it. I don't really see a way around it. What is a C99 framework? It's a framework written in C99. So I'm just using C for all of this. If you want to provide data in world space, how do you do it? I mean, there's no... World space is just it's a convenient term for you to apply to some transformation that you do. There's no mathematical construct of world space, right? You just have to be aware of what transformation space you're in. So if you're in like say I have a quad that's got vertex data, right? And then I apply some scaling to that, I rotate it, I translate it, stuff like that. That's typically what you would consider to be your world space transformation. Okay, so pretty much what takes place in world space. Like entity transformations, physics will typically take place in world space. That's usually, you know, the biggest transformation stack for world space is going to be physics transformations. Then what you have next is view or camera space. So this is taking this, these numbers, this matrix, you know, transformation or whatever, and applying the view matrix to that in order to bring it into what the camera sees. Then you take that and you bring it into projection space. Okay, so that's taking this information and it's projecting it into a unit frustum. Okay, and then you take that and you bring it into clip space. Often these two are kind of the same, right? Because you're taking everything that's in your projection and clipping everything that's outside of it. So now it's normalized. And then you bring it into NDC, and then you bring it into screen or window. And this is what the final transformation is to get it onto the screen that you see. There's nothing mathematical about any of this in terms of this object. There's nothing that says, also you'll hear world and model will get interchanged a lot. But nothing in linear is going to be like, this is camera space, this is projection, right? There are certain transformations, like mathematical transformations that you do, but it's all matrices. So the view matrix is a particular mathematical transformation. Projection is as well. Even model, right? So I use VQS transformations for this. So if I go into math, so this is the model matrix that you get for a VQS transformation. So I take the translation, the rotation, and then the scale of this VQS and concatenate that, multiply it all the way through in order to get this final model matrix. For the camera, so here's the view matrix. So it's taking the up, forward, this is not target, this is right actually. Actually, it's target, yeah, because it's a look at matrix, yeah. In the case you want to use immediate mode as a debugging tool and you want the immediate to draw over something you provide earlier to the pipeline, for example. Yeah, so that's kind of what I'm wanting to do. So if you had something, So maybe this should be that way. So if you wanted to do an immediate mode draw line, you just provide it screen space. Man, how do I want to do this? I mean, the transformations and so on. Yeah, so it probably should be something like push matrix view, or like view times, or not. It probably should be something like this. And then you give it object space, what it is you're trying to do here. But then again, like when you're sitting there, is this an object space line? Because typically you would think, yeah, I mean, although that's world space. So this is even kind of strange. So you would need to do, let's say in your case, I'm thinking out loud here and I'm sounding like I'm rambling, but I'm just trying to think because there's a lot of different ways you could do this. So let's say that we wanted to do what you were talking about, VMA, where you had like a cube that's in the world, right? And it's you wanted to draw like a outline around it. So really we should probably do something like this, where the immediate mode should hold transformation stacks. Okay, so by default, the matrix that it holds, and by that I mean it's just final matrices that it applies to vertices. The matrix that it holds should be an identity matrix at first, okay, and then you would come through and you would push on this projection and view matrix that you want to use, right? You could also, let's say, do something like immediate dot push camera, where you're pushing back a camera into that. Instead of this, you would push and pop cameras. So it'd be something like this. And what that camera does is inside of it, it has a view and projection matrix. So what it's going to do is it's going to grab those and it's going to give you a final mat for like this, where it's going to be the projection times the view of the camera. And then it's going to look at the immediate mode and it's going to push this V matrix onto like the matrix stack. Okay, so then when we come around to grab this, you're passing in world space coordinates for this line at that point. Okay, so that means that this transformation could it could change like if you're used to immediate mode, this transformation could totally change depending on what you provide into the stack. So if you don't have this stuff set up, this could be totally different. So I think I want to do something like that. So like immediate dot push shader, so you can push a shader and pop a shader, right? Immediate dot push texture or enable texture, and then you'd have textures that are applied. So I think maybe that's the way I want to go. So the immediate mode won't be as quick because on the CPU side I'm gonna have to do transformations. So for every vertex that gets pushed into I get it now. The data I send will get multiplied by the camera matrices and automatically be in the same coordinate system. Yes, exactly. So if I didn't do this, at this point, this information now is going to get multiplied by a identity matrix, right? So every single one of these coordinates will get multiplied by an identity matrix. And then when you do that, you're just going to get this information back out. If I want to draw the normals with immediate, I'd push the same matrices of the cube to these lines. You could do that, yeah. So if you knew, like, here's something you could do, right? So if you knew, for instance, the transformation of your cube. So let's say you knew the VQS transformation. Let's say you had a model. Then what you could do is graphics immediate dot push matrix projection times view times model, and then for this right here, you would do something that goes from in this case, these would be object space transformations, right? So you could do, I don't know, like the origin to, like that would be the forward normal. Does that make sense? I think I kind of like this. I was thinking about doing this yesterday and I wasn't sure, but I think this solves a lot of issues, because now what I can do is in this immediate shader, maybe I change all of that. Let me look at Raylib real quick. So we can kind of look at how he does it, and I like a lot of it, actually. I think he has a lot of it structured pretty nicely. Most of my debugging with Opengl has been render doc. Yep. Render doc. So here he has matrix stack, active textures. So let me see how he does this actually. So matrix mode, choose the current matrix to be transformed, push and pop matrices, load an identity matrix, translate, scale, multiply matrix, you set frustum, viewport. Yeah. Opengl equivalent functions to 1.1, 3.3. So this is going to be interesting, trying to do something like this, but then also try to have it later on work around an explicit framework is going to be interesting. And by that I mean a pain in the ass. Texture default, shape defaults. Because let's see, I can probably get this to work, so. Although I'm not sure why I'm still seeing. 0 to I still don't understand why this is this way. Why is it so large? I guess. Just for sanity's sake, if I just draw a triangle, and this goes from this should be an NDC. So this would go from 1, 1, negative 1, 1. Now it should give me a triangle, the bottom left quadrant of the screen, or the top left. Okay. So what I should do is push, I'll push, yeah, push a viewport on to the stack. So I'll transform my immediate mode coordinates by the viewport. I'm gonna have to. That's interesting. I didn't realize that I had that wrong though. Negative top left. Oh, I did bottom right. Well, what's bottom? That's interesting. Yeah, that's what I expected. It's weird. Because this is, I guess it's flipped, so the -1. Yeah, it's not the top of the screen. -1 is the bottom of the screen. That's right. So it means this is bottom left, bottom right. Yeah. Anyway, so what I'll do is, let's do a full transformation here. So we're gonna multiply immediate mode drawing data. Okay, so let's get like a graphics state object. Matrix stack. Really, it's all I care about right now is just pushing and popping matrices. Okay. So we're gonna have. I really don't like the way that's called. Let's just do this for now. Okay. So I think for the immediate begin, we're going to clear all of our stacks. So we'll clear that matrix stack. And then we'll put on the matrix stack an identity matrix. Clear stacks, default stacks, whatever. Okay. I'll do the same thing for viewports. So the viewport is just a vec2. for this, it's actually going to be the platform layer. So we'll just grab the main window and push that onto our viewport stack. Okay. Good, good. And now when we go to actually construct a line, which in that case, I don't need these. I don't care about doing that. I just care about the vertex data. This, I don't care about this. Yeah, these, I'm not constructing these. I'm not pushing back uniforms. This shader, we'll make a shader stack here in a little bit. Instead, don't care about this. We're not doing any of this. I love deleting code. Makes me happy. Set camera. So for now, or later on, what we'll do is that we're gonna have immediate mode, push and pop matrices. So we'll do that for the set camera. Okay, so yeah, so what we'll do now is that we'll get, all right, so we're doing a full transformation here. Okay. So we get the start and end position in whatever space is provided to us. I should do a normal as well. I might need a normal provided as well. So I probably should have something that's like push 3D line vertex data, and then you have to provide a normal, and then I'll have like just a line function. But for now, let's just assume it's a 3D line. So we have this normal here. So, and we'll just use, yeah, let's use that as a normal cross. So that gives us this space. This gives us, let's assume this is still an object space or just whatever. Now we need to transform verts. We have a vec3. No, we need to do vec4. So what we're going to do is grab the back of the matrix, right? Well, let's see. So it's stack. You push onto a stack, so that means it gets pushed to the back. So you want to grab the back element of whatever your array is in order to operate this as a stack. So gs dyn array back. Okay. Let me grab that, multiply it by a homogeneous matrix. Okay, there's our transform matrices. Now we want to perform our matrix divide. So we'll just scale. So TL is now GS vec4 scale. TL by TL.w. Do this for all the rest of them. TR, BL, BR. So now we have our perspective divide. Now we can capture our vertex data. And that is our TL dot position. And that is TL.x, TL.y, TL.z. Okay, and then we push that data back. And that should be it. Now we should, with this, we should get the same thing. So U view. Yeah, I'll set this up in a second. We're not doing this. 7:30. What's your problem? Oh. Okay. Okay, so the same thing. So we're just multiplying an identity matrix through. So now we should be able to push and pop matrices, ideally. So let's see, let's go to our immediate mode, which is up here. So set camera. So let's just do okay. Oh. Hold on, why is that still ridiculous? See, Ethan asks, what's this? I'm adding more graphics capabilities right now. So adding an immediate mode capability. So for like the chicken game you were working on with Gunslinger, this would give you the ability to do debug drawing. So you could do like show where your collision objects are and stuff like that. stuff that I've wanted to add for a while. And with the idea of doing a game jam in the near future, this stuff is going to be important for people. So I still don't understand why that gets passed through. Why is it still... Oh. Not sure what that was about. So 0, 0 to 10, 10. It's still ridiculous. Why is that ridiculous? Is it this? I don't know what this is doing and why. It's pissing me off. I'm gonna step through this real quick. All right, so okay. That should be an identity matrix. Looks like it. Something real quick.
So yeah, I guess I'm gonna need the projection to go through. See, I'm gonna need a default projection matrix, I think. So it shouldn't be an identity, it should be just the screen projection matrix. That's gonna have to be multiplied through, that way it actually wraps to this, or gets projected onto the screen, because right now I'm not respecting that. I think that's the issue. So let me maps, ortho, aspect ratio. So I really just want this. Seeing anything now. I think you just want it, yeah, I just want an ortho. I don't think this is correct. I think it has to be that way. Yeah. Just wondering if maybe I can't see it. No. Okay. What is up? Let's go back into here. Oh. Okay, so that brings me into... Yeah. Okay, and now I want to take this and bring it into screen space, and then I can put it on screen. I think maybe that's it. Maybe. Multiply this by the viewport. Yeah, so my viewport, GS-Spec2 viewport. Viewport stack. But do I need to transform this? Do I need to bring this into... I think I do. Shit, I'm gonna have to map this now. Because I think I have to map this into 0 to 1. This could get expensive. Let me go and come to here. Okay. So this is after the perspective divide. Now we're at -1 to 1. Oh. Yeah. That's fine. We're outside of clip space, but it doesn't matter. That all looks right. So we're in a -1. But we want to bring this into window space for our final transformation. So what we're going to do, right? I think so. So what we're going to do is actually transform this by... So you should be able to do... Yeah, I think so. I don't know, this might not be correct. I'm gonna need to map this stuff into... Pretty sure I have that util in math. Yeah. So we're going from -1 to 1, and we want to go 0 to 1. I think this needs to be flipped. This is what your GPU does for you, by the way. Yeah, so we're mapping that, and now we want to multiply. I don't know if this is gonna work. Shit. numbers. Does that even make sense? Yeah, I don't know. Damn it. So an orthographic projection. If I just do a default camera? really give me anything different. Man, I'm thinking about this wrong. These need to be swapped. Man, this I still shouldn't have to do all this. This should all be handled. I shouldn't have to do any of this. I should be able to say, well, no, yeah, because I gotta handle it. Okay. Man, what the fuck am I missing? Let me just do it up here. Should we be able to scale this? Okay. All right. I think I am gonna call the stream. I'll have to figure this out here in a little bit. Just wrap my head around it. But I'll figure this out and then I'll see you guys later. All right. Hey, thanks, Rudy. Appreciate it, man. All right, see you guys.